Hello, my name is Natalia from Idaho State University, and today I will be introducing and demonstrating the use of the Advanced Active Learning Module, or the ADALM2000. It is also called the M2K for short. The M2K is a device that is capable of providing the functionalities of several different types of analog and digital electronic lab equipment. Upon opening your M2K box, you will notice some 6-pin headers that it can be used for plugging the device into a breadboard, and a 20-wire set of digital probes, a 10-wire set of analog probes, the M2K itself, and a USB cord used to connect the device to a laptop or computer. For the first set of demonstrations, I will be using the analog probes. To connect the probes to the M2K, simply insert them into the leftmost side of the bottom of the device. Prior to plugging the M2K into your laptop, it is crucial that you first install the required driver software. Additional application software called Scopy is also required so that you can use the instrumentation functions of the device. A link to the necessary software and some basic download instructions along with an instructional video is provided in the description of this video. Once the software is properly installed, the M2K can be connected to the computer via the provided USB cord. It is important that the small end of the cable is connected to the middle top portion of the M2K labeled with the matching USB symbol, not the power port. Now the other end of the cable can be inserted into the USB 2.0 port of the computer. The blue ready light should now stay on, and the LED 1 light should be flashing. On your computer, find and double-click the Scopy icon and view the startup screen as shown here. Left-clicking on the M2K icon should change the screen to this, and once you've reached this point, you can connect the M2K by simply clicking the Connect button. The words connecting and then calibrating will appear until the device has fully connected. So there, it's calibrating now, and now it's connected. So with it connected, we can now use the many different instruments it contains. The menu list on the left-hand side shows 9 different lab instruments available through this device. We have already gone through the 9 lab instruments in a previous video, and this video will demonstrate the use of the oscilloscope, the signal generator, the voltmeter, and the power supply. As mentioned in the previous video, a power supply is simply a tool that allows one to supply power to a circuit or component. The M2K can provide any amount of voltage ranging from -5 to 5 volts. To demonstrate the power supply, we will use a breadboard, a header, and the red and white leads from the M2K and one of the black ground wires. These wires correspond to the V+ and V- pins and the ground symbol pins from the pin diagram of the M2K. So to set up this tested power supply, we will insert the 6-pin header into the breadboard, and we will insert one of the ground wires to one end and a red to another, and we could put the white somewhere in the middle. So here we have the power supply connected to the breadboard, and we can now go to the computer and enable a voltage from each of these wires. So for this demonstration we'll use 3 volts, but we could go up to 5. So 3 in that one, and we'll do -3 here. And so we just enable those, and that voltage should be delivered to our breadboard. And right now we will confirm that this is true using the voltmeter function. So as mentioned in the previous video, the voltmeter is a device used to measure voltage in a circuit or across individual components. In order to demonstrate the voltmeter, I will be using the power supply connections from the previous example, including a couple more red and black wires and some of the analog probes from the M2K. So I will be using both the orange and blue analog leads, labeled 1+, 1- and 2+, 2- respectively, on the pinout diagram of the M2K. So these 2 different colors, the blue and the orange, represent the 2 channels of the voltmeter, which can be used to measure voltages. So you can do 2 different measurements. And so we'll just connect some wires to these so that it's easier to connect them to the breadboard. And there's the lower wire with the white stripe. And so here for the blue it's the same thing. The upper wire is solid. And the lower wire has a white stripe that we'll look at. You can kind of see. And so then we'll connect these across the power supply wires so that we can measure and confirm that that voltage is being delivered to the breadboard. And you must ground all of that too so that you can get an accurate measurement of the voltage. And so there, we'll do the white lead as well on channel 2. You have to ground that as well. And so once these are connected, we can go back to the computer. We'll ensure that we're connected. Good. And then we can check and confirm that the power supply is functioning correctly and delivering the voltage. So we should expect a +3 on channel 1 and a -3 on channel 2. And we see that that's approximately what we get, a little higher, 3.07, and then -2.9795. So we get the results as expected for the voltmeter as the power supply delivers that voltage. From the previous video, we know that the purpose of the signal generator is to produce signals of varying characteristics necessary to analyze a circuit. The signal generator capability is demonstrated by use of the yellow wires. These are labeled W1 and W2 on the pinout board. So by simply placing either of the wires onto the breadboard through use of a header in this case, we can enable a signal onto the circuit. So back on the computer, we can use the signal generator to generate a signal through use of that W1 wire, and today we'll be using a waveform. We can set the characteristics of this waveform. We'll do a sine wave with 2 volts amplitude, and let's do 1 kilohertz frequency. And so when we press run, it'll generate that signal for us onto the breadboard. So in order to confirm that the signal generator is functioning properly, we can use the oscilloscope, which will display a graph of voltage over time. And so we can check and see if that signal, that sine function, was properly generated. So we can use the same breadboard setup in the previous example, and we will use the orange wires and a ground wire to use the oscilloscope to measure that signal. So we just need to connect that channel 1 set in line with the waveform. So we'll have to ground the other one as well. As we've done in previous examples with the voltmeter, it's the same process. And so then we go back to Scopy and we switch from the signal generator to the oscilloscope. Make sure the signal generator is still running and click run here and ensure that you're on channel 1 because we didn't connect it to channel 2. So channel 1, we can press run and we see our sine wave here. And with the 1 volt per division, we can see that that is the correct amplitude. We get 2 volts. And then you can also use the measure function to see the peak to peak is 2 volts and the frequency is about 1 kilohertz. So that confirms that our signal generator is working and we get to see the oscilloscope. We can change the vertical and horizontal scaling of the oscilloscope to show us the signal with a different time base or a different number of volts per division. We can stop this oscilloscope from running, or we can do just one single sweep and you see that the measurement stays stable. And then we can turn off the signal generator as well and go back to the oscilloscope and see that it shows nothing. So that's another way to show that that is what it is measuring. So when you're finished using the M2K, you have to remember to disconnect all probes from any circuits or components and also ensure that every device is turned off. So we see here none of them are green check marked, so we can go back to the home menu and press the disconnect button. So there, it's disconnecting. And so we're good, and then you can also exit out of that and disconnect it from your computer, safely eject the hardware, and then you can unplug the device from your computer. And failure to complete this disconnection process can permanently damage the M2K, so it's really important that you follow this process of disconnecting the device. Finally, here are the references I used to make this video. I hope you have found this video helpful and that it has increased your understanding of the M2K and some of its basic functions. The ones outlined here in this video were the power supply, voltmeter, signal generator, and oscilloscope. If you have any questions about anything I've shown in this video or questions about your course in general, please feel free to contact your professor or lab TA via email. Their contact information is available on the class syllabus on Moodle.